And I'm back. And there. Okay, so here I go. I'm looking at the mid segment of a triangle now. And then I'll be looking at angle bisectors. And then I'll be looking at medians. So let's get started here. In each triangle, M, N, and P are the midpoints of the sides. Name a segment parallel to the one given. So the line segment PN is parallel to the line segment CD. Here, the line segment NM, the line segment MN is parallel to the line segment QS. And we check. And that's correct. Find CD. In other words, find the length of the line segment CD. That should be 1/2 of 16, which is 8. Find the length of the line segment AC. That should be twice 4, which is 8 as well. Find the length of the line segment KJ. By the mid-segment theorem, that should be 9. And find the length of the line segment IK by the mid-segment theorem, that should be 10. And we check, and that's correct. They're all correct. Find the length of the line segment DF. By the mid-segment theorem, that should be double the length of the line segment VU. So double 9, and we get 18. Now find PQ, the length of the line segment PQ. Okay, well, Q2S is, shouldn't PQ just simply be 15? I'm actually perplexed by that, why they're asking that. Should be 15, right? And it is, and that's all good. Okay, solve for x. All right, well, we know that the double of 2x take 3 is equal to x plus 9. So expand and solve, and x is 5. By the mid-segment theorem, the double of x plus 19 is x plus 29. So expand and solve. 29 minus 38, so that would be minus 9. Check. And that's correct. By the mid-segment theorem, the double of x plus 2 is 3x minus 8. So 2x plus 4 is 3x minus 8. And solve. So x would be 12. By the mid-segment theorem, the double of x takes 3 would be x takes x plus 6. So 2x takes 6 is x plus 6. So solve now. So x takes 6 is 6, so x is 12. and check. And they're both correct, and that's good. Now find the missing length indicated. The missing length indicated. So we are to find the length of Ln. So if double x at 2 is x at 10 by the mid-segment theorem, then 2x at 4 equals x at 10. So x is 6. And now the length of Ln is 6 plus 10, which is 16. We need to find the length of RQ. So we know that 2 of x take 2 is equal to x at 3. So 2x take 4 equals x at 3. So x is equal to 7. And if the length of the segment RQ is x take 2, then the length of the segment RQ must be 7 take 2, which is 5. And we check, and that's correct. Find the length of SR. Well, I guess 2x take 14 applies to that. Not 100% sure. So 4x take 28 is equal to x at 2. So 3x is equal to 30. So x is equal to 10. And so now for RS, that would be 2 times 10 take 14, which is 6. That would be the length of RS, segment RS. SR, beg your pardon. Now we must find the length of segment VW. So we know that 2 times x at 15 is equal to x at 21 by the mid-segment theorem. So 2x plus 30 equals x plus 21. So x is equal to 9. No, incorrect. X is equal to negative 9. And so VW, the length of segment VW, must be negative 9 plus 15, which is 6. And we check, and that's all correct, and that's good. Next up, angle bisectors of triangles. Each figure shows a triangle with one of its angle bisectors. And we have 16 problems to solve, and so we'll begin now. So the measure of SUT is 34 degrees. So find the measure of angle 1. Well, as it's an angle bisector, surely it would be 17 degrees. The measure of angle SQR. Find the measure of angle SQR if the measure of angle 2 is 13 degrees. That would be double, so 26. And they're correct. The length of PT is 3. Find the length of PU. Each figure shows a triangle with its 3 angle bisectors intersecting at point P. So I believe that the segment PT and the segment PU are congruent. So 3. Likewise here, 7. Okay, but I want to know what the name of this is here that I'm intuiting. So I'll find out about it. Okay. Yeah, that's the centroid. I know about that. Do I? Do I, though? Do I actually really? No, I don't. Okay. It does appear to be the centroid. That would be the centroid if you just sort of extended them. Yes, it would be. That's the centroid. All right. Okay. So anyway, well, that's 5. And that's 8. Okay. Okay, so here, I know that hy is 3. No, sorry, I have to find hy if I know that py is 2 and hp is 3. Okay. So the Pythagorean theorem. So 3 squared, which is 9, 2 squared, which is 4, 9 take 4 is 5, so root 5. Find AP if PQ is 1 and AR is 2. When I'm supposed to find AP. Well, RP would be 1. And so 2 squared dot 1 squared is 5, and so root 5 as well. And check. And that's correct, but they did it to the nearest hundredth, I guess. And here we go. PT is 5. And FP is 7. So find FT. So 49 take 25 is 24, and root 24 is 2 root 6. Which I must approximate. So 4.9. PT is 3. This is 8. 3 and 8, we need to find that. So 64 take 9, which is 55, and so root 55. 7.4. And we check, and that's all correct. Find PB if UC is 2. and UP is 3. So 3 squared take 3 squared take 2 squared is 5. So root 5 there. So 5 there, which is about 2.34. 2.24. PS is 3. XP is 5. So find XS. So 25 take 9, that's 16. So 4 is 3, 4, 5 triangle. So 4. And check. And that's correct. And that's good. Each figure shows a triangle with one of its angle bisectors. Find x if the measure of angle 2 is 4x at 5 and the measure of angle 1 is 5x take 2. Okay, if it's an angle bisector, then these two angles are equal. So 4x at 5 is equal to 5x take 2. So take 4x from both sides. So we get x take 2 equals 5. So add 2. So x equals 7. Find x. The measure of xvw there. So 2 times 1 at 28x is equal to 59x take 1. So 56x plus 2 is equal to 59x take 1. So 3x take 1 is equal to 2. So 3x is equal to 3. So x is equal to 1. And we check. And that's all correct. Find the measure of angle 1. Find the measure of angle 1. Okay, so 16x at 4 is the double of 7x at 7. So 16x at 4 equals 14x at 14. Take 14x from both sides, so 2x at 4 equals 14. Take 4 from both sides, so 2x equals 10. So x is equal to 5. But we need to find the measure of angle 1, so 35 at 4 for 35 at 7, so 42. Now find the measure of angle 2. If it's 7x at 5, and the measure of angle 1 is 9x, take 5, so equate them. Then 2x take 5 equals 5, so 2x equals 10, so x equals 5. But we need to find the measure of angle 2. So sub, and the measure of angle 2 is 19. No, that's wrong. The measure of angle 2 is 40. And check. And that's correct. And that's good. Okay, now to look at medians. So the median in statistics is the central element of an ordered data set, or it's the center of the two central elements, the mean of them. But in geometry, it means something different. What it means is the length ft is congruent to the line segment ft is congruent to the line segment te, which means they have the same measure. They're equal in length. So find fe if te is equal to 8, so 16. Find gf if tf is equal to 6.3, so double that and we get 12.2. 6. And check. And that's correct. And that's good. Lj, if ij is 6, so Lj, the length of Lj must be 3. Now find the length of Nm. If Em is 10, well, that must be 20. Find Zq, Zd is 6. Z to D is 6. And we need to find Z to Q. So I think it's 2/3 of 6. It's 2/3. Right? Find our K if dk is 3.4. So 10.2. So 3, so 20. So 4 and 10.2. Okay. Find BG if BV is 3.9. So BG would be 2/3 of 3.9, which is 2.6. But I need to know what that theorem is called. Can't just use it. I guess it's just called the 1/3, 2/3 rule. So I'll just employ that name henceforth. Find Ez if Zv is 12. So that would be the double of it, which is 24. Find dh if bh is 4.5. So that would be 2/3, which is 3.0. Find cg if kg is 41.4. So that would be 1/3. Which is 13.8. And we check. And it's all nearly all correct. But this says 3.0 and it shouldn't. What's going on is that I had a lapse in concentration. Okay, find x if GE is 3x plus 5, and IE is x plus 6. Two x at 6 is equal to 3x at 5. So x is equal to 1. Find x if TP is this and TQ is this. Okay, so they are equal, so just set them equal. 2x at 1 is equal to 3x take 5. So x is equal to 6. And check. And still not getting this right. And I need to understand why that's not right. Because it's equating the wrong things. It's not 2x at 6, it's 2x at 12. Simple error. That's better. Okay. Find x if ET is 3x at 2. And EM is 5x. So 2/3 of the whole of 5x. The whole of 5x. That's equal to 3x at 2. So what you do is you times, you just times across. And then you say that x is 6. Find x if KT is that length and KB is that length there. No, wrong. Two-thirds of this is equal to that. So now times across. And times out. And we get 4x on the right and 30 on the left, and x is equal to 7.5, I believe. And that's correct. Next. Find CQ if CR is x and CQ is 2x take 6. So 2x take 6 is equal to x. So negative x is equal to negative 6. So x is equal to 6. So the length of CQ is 2 times 6 take 6, which is 6 itself. find the length of AS. If you know that AR is x take a half, and AS is x at 5/2. So equate them. And times everything by 2. And take x from both sides. So 5 is equal to x take 1. So 6 is equal to x. But we need to find the length of AS. And so put in 6. And so 6 at 5 is 11, and 11/2. Or 5.5. And we get that that's correct. Find xq if mq is this, and xq is this. So 2x take 6 is 1/3 of 3x take 3. So 2x take 6 is equal to x take 1. So x take 6 is equal to -1. So x is equal to 5. But we need to find xq. So 2 times 5 takes 6, which is 4. Find JW if you're told JW is this, and you're told that JB is this. So in other words, you're told that 2/3 of 10x add 1 is equal to 6x add 2. So now times across, so 20x add 2 is equal to 18x add 6. I deduct from both sides, so 2x add 2 is equal to 6, so 2x is equal to 4, so x is equal to 2. But we need to find the length of JW. So 6 times 2 at 2 is 14. And that's correct. And that's all good. Be well.